let's talk about our first chapter, the WinCC OA data point concept. So if you think about SCADA and if you think about PLCs, we want to visualize system states of real devices in the outside the world. So let's assume we have here a motor-driven valve, and if you think about this real device, there will be a PLC attached, and you can change the state from open to close. And in WinCC OA, we will always do a data model of the real device. And a data model, a good data model, will not be a complete copy of a real device, because in a good model we'll only visualize or only take the items or the data points or the characteristic of a simplified version of the real device. So let's say if we think about a motor-driven valve, we will have here, for example, we can structure it, let's say it like that, into a command branch and a response branch. And if you think about, if we want to send some data to the motor-driven valve, that can be done on a set point. So we give our wish to the set point data point. The motor-driven valve will fulfill this task and drive to the wished set point, and we'll get a feedback about the actual value, or if the state is completely open, or if the motor is running, or if we have a closed state, or maybe we have a malfunction on the travel limit. So an alarm is triggered, or we have a problem with the temperature of the motor, and related to that causes an alarm. So we do always a data model in WinCC OA, which holds structure and type assignments, and we do it in an object-oriented way. So we will always do a so-called data point type first, which is the same as a class on object-oriented programming, and then we will create an instance out of it, which will then be our real data model for this device outside in the world. We do it in a different way as most of the SCADA systems are doing that, because if we use lists, then lists are always difficult to understand, or maybe difficult to maintain, and modifications can be necessary on different places. So that's why we skip the idea of mappings and lists, and we will do an architecture like that. Let's assume that here is a motor-driven valve, which is then separated in two branches, one in command and one in response. And here are the data point elements, where we have or can have type assignments on it to hold the system states of our device. So if we take a look on the concept board, then I would say, again, everything starts with a so-called data point type, which holds the structure and the types. The data point type, out of this class, we can create data points, right? And these data points can have data point elements, which means that if we look at that, the valve will be the data point name, and every deeper item here will be a so-called data point element. And data point elements can have configs. So let's go ahead on here. But first, we will see here that every data point element here can have a type assignment or not. If there is not a type assignment, it will be a so-called structured node, or it has the type struct, which is a kind of complex type. And then we can do assignments like bools, int, floats, characters, strings, or more complex ones like arrays, dynamic arrays, or blobs, which is a binary large object, for example. And if we define the structure and the type, we will define the data point type, so the first one. And out of that, we can then create data points, and you can create as much data points as you want. And we can assign configs. So there are 21 configs available in WinCC OA, and every config has attributes, and there can be only 2 attributes or in huge amount of attributes, like more than 100, for example, on an archiving config. So what is a config? A config is more or less a functional unit which holds some data and can perform some tasks. So for example, we have the original or online value config, which means the original data is able to be stored on a data point element, which means also that if there is a type assignment, automatically it is able to store the data on it. Or you can do a value range. So for example, let's say we have the case that we are dealing with a data point element with a floating type, and we will restrict the range of this floating type. So we can then perform and add a value range config on it, and for example say the good range will be from 0 to 100, and everything's below or beyond this range will be ignored or will act in a replacement of the data from a so-called default value, for example. Or we do a conversion config on it, which is more or less the engineer's value to the raw value. So think about, you have a water tank, right? So we have this water tank, and this water tank is filled with water, right? And the PLC pump is dealing here with liters. But in the SCADA system, I'm not interested in how much liters is inside, because I have to compare it somehow. So I can directly say, okay, 1000 liters will be the same as 100% filling state, right? So I can have more or less a calculation from the engineering value in the SCADA system to the raw value, which is then taken in the PLC, for example. Or we can do an archiving config on it, which gives us the feature to store our data in a historical way. Or we attach an alert handling, so we can act on the values itself. So if we define alert ranges and we are crossing these ranges, then we can create an alert or alarm in WinCC OA and display that in our alert rows, or our custom object we created with our graphical editor, and so on and so on. So during the next 7 days, we will go through all these 21 configs and their attributes. So to summarize that a little bit, we always want to create a data model which is representative for a real device in the real world. We will always, or we have always, to do a data point type first, which holds the structure and the type. And out of that we can create real data points, which will be then linked to our PLC tags. A data point can consist of several data point elements. It's not a must-have. And data point elements can have configs. During the week, so tomorrow or on Wednesday, we will also talk about a master data point, which makes us the management for the configs a little bit easier, so that we can generate a single point of maintenance for configs, but later more to that.